Welcome to episode 22 of CipherVibe's end-to-end cloud security architecture course. Threat detection and analytics turn cloud evidence into decisions about suspicious behavior, risky posture, and attack paths. The objective is not more alerts. It is faster, explainable action on the events that matter. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Detection consumes centralized logging, identity context, network and workload signals, vulnerability and posture findings, data classification, and response playbooks. It should feed improvement back into prevention and secure delivery. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is use each platform for its strength. CM platforms centralize event analysis and correlation. CSPM focuses on cloud inventory and configuration posture. NAP approaches connect posture, workload, identity, code, and exposure context. Define the decision each tool supports instead of expecting one dashboard to replace every control. The second building block is prioritize with context. Prioritize using the combination of public reachability, identity privilege, data sensitivity, vulnerability or misconfiguration, lateral movement path, business importance, and observed behavior. Explain why an alert is important in terms a service owner can verify and act on. The third building block is engineer detections like products. Write detections as hypotheses about observable behavior, identify the log sources and expected fields, test them against safe samples or replay, assign an owner, and measure false positives, coverage, and time to useful triage. Retire detections that create work without reducing risk. The fourth building block is protect the analytics pipeline. Monitor data freshness and parsing, normalize identities and assets carefully, protect investigation access, and preserve raw source links for analysts. A graph or correlation engine should reveal uncertainty and provenance rather than conceal incomplete data behind a confidence score. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The reference detection pattern enriches reliable events with asset and identity context, evaluates tested analytics, explains priority, and routes a small number of actionable cases to owners with response options. Implement this layer in a sequence that preserves evidence and limits blast radius. First, choose priority threat scenarios and define required evidence. Second, verify logging, asset, and identity coverage for those scenarios. Third, build and test a small set of high-confidence detections. Fourth, enrich alerts with ownership, exposure, and data context. Fifth, measure triage quality and feed confirmed lessons into controls. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, measuring success by alert volume or vendor coverage. Second, correlating stale or incomplete inventory data into confident risk scores. Third, deploying detections with no owner or response procedure. Fourth, automating containment from low-confidence alerts. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, replay safe representative events and confirm expected detections. Second, measure evidence freshness, detection coverage, and false positive rate. Third, review analyst access and raw event provenance. Fourth, exercise escalation and response for one high-priority scenario. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design a detection for suspicious cloud role elevation that includes identity, approval, source, and target resource context. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that threat detection and analytics becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.